Okay, so now we're going to go into a new gas law called Charles's gas law. So let's go ahead and get started. So, Charles's law is a direct relationship. What that means is if the temperature goes up, so does the volume. Kinetic molecular theory is what supports Charles's law. That is saying if the temperature goes up, the gas particles move faster, sticking to the walls of the containers more frequently with greater force, which would cause the volume to go up. Pressure depends on the frequency and the force that would be released because of this. So it gave us two examples. The two examples that it gave us is it gave us two containers. One container had 1.0 liter. The other one had 1.0 liter. But then what happened is you have something that had pressure on both of them. We have 1 atm and 300 milliliters, and it's not heated. But then when it heated, it pushed the piston up, which changed it to 600 milliliters with 1 atm. Okay? So when we do that, it was just basically talking about you have two graphs here. You have a graph of volume in Celsius temperature versus the volume of Kelvin temperature. As you can tell, they're similar. The only thing that's different is this starts with the negative 300, and this has what's called absolute zero. So on the Kelvin scale, shows zero, that is absolute zero. What is absolute zero? Is the lowest possible theoretical temperature. So then it introduces us to Charles's law, which is V1 over T1 equals V2 over T2. We need to make sure that we have to remember if our temperature is in Celsius, we have to convert it to Kelvin. To convert it to Kelvin is 273 plus whatever the temperature of the Celsius is. And so let's look at the example problem. Now, I want to tell you, I do things different than the book, okay? I feel that the book is a little bit confusing on how to rearrange this equation. So if you watch the video, it's probably going to help. But if it confuses you and you want to do it the book way, I don't care. It's the same thing. Only thing it is I'm doing an extra step, okay? So the problem on the book says a helium balloon with a closed car occupied 2.3 liters. Okay, so we have our 2.3 liters. That is going to be our volume, and the temperature was 40 degrees Celsius. And the car was parked on a hot day, and the temperature inside rises to 75 degrees Celsius. What is the new volume? So the first thing I do is I write down the law, V1 over T1 divided by T2 over V2 over T2. And then what I do is I crisscross and I make it linear. Because if I make it linear, then I can do the same thing I did with Charles's law. I just have to write it out, find the unknown, divide both sides by it, and then I can have the variable by itself. Okay? But then the first thing I want to do is I can remove the unknown. So I have V1, T2, V2, T2. I am looking for V2. So since I'm looking for V2, I got to take T1 and I need to put it over here. Okay? So that crisscrosses it out. The next thing I need to do is I need to change to Kelvin. Well, these are in Celsius. So 75 plus 273 is 348. 40 plus 273 is 313. Okay? So then I'm going to put it in the formula. So my V1 is 2.3 liters. And so if I'm doing it with my calculator, which I think it's going to be able to be seen on here, I first of all would do alpha Y enter. Let me turn it on first. Alpha Y enter. Alpha Y enter. Sorry guys. So then I'm going to do open bracket 2.32 close bracket. Open bracket 3.48. Close bracket, go down, 313, and if I hit enter, I get 2.57942, and big number, right, to the negative 2 power. Well, let me change my mode to normal mode. because I don't need to have a big number. And so basically what I have is I have 0.2579. Well, I'm just going to go ahead and say it's 2.58 liters. Okay? So, question number 1 on the practice problem says, what is the volume of gas in the balloon on the right? So the balloon on the right, we have 4.3 liters and we have 350 Kelvin. Okay? We've got that already, and now I'm going to go ahead and say it says the volume of the gas in the balloon is right as 250 K. So, my first volume is my 4.3 liters. My first temperature is 350 Kelvin. My second volume I don't know, and then my temperature is 250 Kelvin. So the first thing I'm going to do is I'm going to go and write out my law. Then the next thing I'm going to do is I'm going to get rid of the unknown, because what I want to get V2. Now the third thing I needed to do, I needed to change it to Kelvin, but guess what? They're already in Kelvin, so I don't need to do that. So then only thing I got to do is plug it in. So that is 4.3 times 250 divided by 350, and I get 3.07 liters. Okay, so that's question number 1. So question number 2 says, a gas has 89 degrees Celsius. That's my temperature 1. And occupies a volume of 0.67 liters. That's going to be my volume 1. At what Celsius temperature? So this is asking for Celsius. Okay, so I'm not even going to convert it to Kelvin this time. I'm going to keep it in Celsius this time. The volume is increased, so I want to find out what the temperature is. That's temperature 2. If my volume is 1.12 liters. 1.12 liters. So the first thing I'm going to do is I'm going to write out the gas law. V1 over T1 equals V2 over T2. The next thing I'm going to see is what am I missing? T2. So then I'm going to go ahead first of all and make it linear. V1 crisscross T2 equals V2 T1. Now, you could do T1 V2. I don't care which way it's in order. It doesn't matter to me at all. Don't care. So now what I'm going to do is I say, all right, T2 is what I need to miss. So I'm going to divide both sides by V1. And if I do that, guess what? T2 is by itself. Now what I'm going to do is I'm going to plug in my numbers. So my V2 is 1.12 liter, right? I'm going to multiply that by my T1, which is 89 degrees Celsius. And I'm going to divide that by 0.67 liters, which is my volume. So, here am I. Alpha Y, enter. And I've got 1.12 times 89, because I'm not going to change it because it's asking for the answer in Celsius, divided by 0.67, enter, and I get 1.487. So I'm going to go ahead and write this down, 148.77611194, and guess what I'm going to do? Now what I'm going to do is I'm going to do my check answer. Well, T2's on the bottom, so I'm going to start with this first, 1.12, right? Or I can do it this way. I'm going to do it this way. I'm going to do it linear. 1.12, and I'm going to divide that by my second answer, which is that one right there, right? And that's going to give me a check answer of 0.007528089. Now, I'm going to do this side. 0.67 divided by 89. Same check answer. Circle and do that. My answer now is going to be 149 degrees Celsius, right? Because I'm just rounding that up, and I have my check answer. Now let's go ahead and do question number 3. So, question number 3. Question number 6. The Celsius temperature, so number 6 said the Celsius temperature of a 3.00 liter of a sample gas, that's my volume 1, is lowered from temperature 1 is 80 degrees Celsius to 30 degrees Celsius, that's my temperature 2, what is the resulting volume? So my volume 2 is what I'm looking for. Listen, you always have to read the problem, write out your variables, and check it. Okay? So now I've done that. So the next thing I'm going to do is I'm going to go ahead and write what my equation is. V1 over T1 equals V2 over T2. Next thing I'm going to do is I'm going to crisscross. V1 T2 equals V2 T1. I am looking for V2, so I'm going to divide both sides by T1. All right, and now I'm going to plug in my numbers. But before I plug in my numbers, I'm going to change my temperature. My temperature 1 was 80 degrees Celsius, and I'm going to add 273 to that. So I'm going to say 80 plus 273. 80 plus 273 is 353. So that's my first temperature, so I'm going to mark that out and put 353 because I want to do that. The next one is 30 plus 273, and that's my temperature 2. 303. Okay, that's my Kelvins. Done that. Next thing I'm going to do is plug and chuck. So I got 3.00 liters. I'm going to multiply that by 303 Kelvin. And I'm going to divide that by my T1, which is 353 Kelvin. And so K and K maxes out, and L is what I'm going to have my answer for. So I'm going to do alpha Y, enter. I'm going to do open bracket 3.00, close bracket, open bracket 303, close bracket, down 353, over, enter, and I get 2.57507.08, 0822. So now what I'm going to do is I'm going to plug it into my original formula, which I'm going to take this answer, and I am going to divide that by 303, and I get a check answer of 95836 is my check answer. I'm going to go over here, 3.00, and I'm going to divide that by my 353, and I get the same check answer, and voila, check answer. Okay? So, like I said, if this helps you out, that's fine. Tomorrow you're going to have some practice problems, which you already have a copy of. So I hope you have a blessed day.